4.1 one-to-one functions and their inverse. What was the one-to-one functions, inverse of a function, graphing the inverse of a function, and finding the inverse of a function on a restricted domain? And let's start with one-to-one functions. Now, if a function doesn't take the same value for different 2x values, f is said to be one-to-one. So the important thing is, if f doesn't take the same value, same y value for two different x values, so it means for any x value we have only one y value. So this for two different x values we don't have this. We just have a one-to-one matching between the domain and the range here. So like that, it's like that. So we don't have this type of thing. It doesn't go to the same y. So no two x values go to same y value. So let's look at these examples here. This is not one-to-one. An easy way of seeing this is to show the matching between the values 1, 2. F matches them 2, 5, and 3, 5. As you see here, f takes the same value, which is 5, for two different values of x. So this part of the function is breaking the rule, so it's not one-to-one. So this is not accepted. Now let's look at this example here. Now, if you want to see it's one-to-one, you have to check, okay, 1 goes to 2, 2 goes to 5, and 3 goes to 6. As you see, there is no 2x values coming to the same y value or assigned to same y value. So this is okay, so this is one-to-one. Now, we can have a function with formula. Okay, a function can be given this way, and most of the time it will be given this way. This is not one-to-one because of this. So when you put one value, you can find two values, 1 and -1, for example. So they come to the same. Okay, they give the same y value 1. So 1 and -1, they go to the same y value. So 1, as you see, 1 squared and -1 squared, they're same. So we have this one here. H is assigning 1 to 1 and 1 to -1. So this is not wanted. So it's not it's not one-to-one because of this. Now let's do this example. Decide whether the following functions are one-to-one. Now, from the picture, it is clear that this is not one-to-one because two different values of x is assigned to a value, to same value. So this is not one-to-one for sure. And look at this one here. If you can find, so this is not easy to see from the formula of the function. If the function is given this way, so it's hard to show it. It's one-to-one, but it's easy to show if it is not one-to-one. Now, since it's x squared, you can put a negative number here, -1. It makes 1, and positive of the same number, it's 1. F of 1 is equal to 1 squared. It makes 1. So as you see, for different values of x, we got the same y value. So we have this case. So f is making this. So this, it says it's not. This means it's not one-to-one. Now we can check when the graph of a function is given to us. We can check if it is a one-to-one function or not by looking at its graph. So we will use a test for it. The name of the test is horizontal line test. Here is the important information about this test. A function is one-to-one if each horizontal line intersects the graph of the function at most one point. So let's see this one here. For example, let's look at this one. So this horizontal line, you can see a horizontal line is passing through the graph of y at 2 points. So in this case, you have 2 points. So what does this mean? For different x values, so let's say this is x0 and this is x1, we don't know them exactly, but there are two values for sure. They come to the same y value on the graph. So for this reason, this is not one-to-one. And now, when you look at the graph of this function here, this is a line. So when you draw any horizontal line, you can see always there is one intersection. So the line, any horizontal line, intersect the graph at only one point. So it means for any y value, there's only one x value corresponding to it. But so for this reason, this is one-to-one. Now, when it comes to here again, for this y value, we have two x values. So and also you have x squared. The same issue is you can check with the formula here. F of minus 1 gives you 2, and f of 1 gives you 2. So you see it's not one-to-one also. Now let's look at this example. Determine whether the following functions are one-to-one or not using their graphs. So we can use the horizontal line test here, but first we need to make the graph of these functions here. X cubed as this graph, and the absolute value of y has this graph. When you use the horizontal line test for x cubed, as you see, any horizontal line is passing through or intersecting the curve at only one point, so it is one-to-one. Now, when it comes to the absolute value of x, as you see, we can find our horizontal line intersecting the graph of absolute value of x at only at 2 points, so it's not one-to-one. And also, you can check this function is not one-to-one by picking two values, like g of 1 is 1 and g of minus 1 is 1. As you see, we have the same y value, but we have two different x values. You can say it's not one-to-one. Beside the graph, you can also check the formula and show it's not one-to-one. And showing, if you want to show it's one-to-one, it's better you use all the time the graph, because we don't have, for now, we don't have any method to check if it is one-to-one from the formula of the function. So inverse of a function. So inverse of a function, f, is the function that assigns f of x back to x. So this is the situation here. This f is taking one x value and bringing or assigning another value, which is f of x, to x. So f is doing this. Now, the inverse of f is doing this. So if this is the first, assignment here by the rule f, so the inverse of f should do this. So this is inverse of f function. So generally it's denoted by this f minus 1 here. Anyway, we will see that for now we will see it as g. Okay. Now this is what the inverse function does. Okay, if g is the inverse of a function f of x, so it will take f of x back to x. It means g of f of x is equal to x. And the other thing we have to know is if g is the inverse of f of x, then f is also the inverse of g. So it means f of gx is equal to x. And this is the very important one here. Only one-to-one functions have inverse. So for example, this function doesn't have an inverse because it's not one-to-one. Look at the horizontal line test. So this is not one-to-one, and it doesn't have an inverse. So one other thing, the problem here, it comes like this. So if, okay, the absolute value of 1 is 1, the absolute value of -1 is also 1. So if you define an inverse function, then the question here is this. So you have this function, the absolute value function is doing this, like takes 1, 1, and 1, -1 to 1. But if you want to go back, so we have two values. So which one should we prefer? So this is making the problem here. Since it's not 1 to 1, we have an ambiguity here, and it prevents the function to have an inverse. Okay, let's look at this example here. So it says in the example, show that g of x. Okay, this is very weird, but anyway, let's look at this question here. Show that g of x is equal to x plus 1 over 2 is the inverse of f of x, which is 2x minus 1. So to show this one, we have to show g is taking f of x to x. So it means you have to put g of f of x and so you have to calculate this value. And what is f of x? F of x is 2x minus 1, and you will place it here. And then what is g of 2x minus 1? Okay, how do you calculate? Let me remind you, g of x is x plus 1 over 2. So here, instead of x, you see 2x minus 1. And then you put here for x, you put 2x minus 1, and then plus 1 divided by 2. So after this cancellations and the simplifications, you will get x. And this is what we want to show. And the other thing, if g is the inverse of f and f is the inverse of g, then we will also show the second equality here. So f of g of x, and let's put this g of x here. Substitute its formula, x plus 1 over 2. And then, so you will calculate this. Okay, you remember you see x here. Instead of x, you see x plus 1. Then you do the same thing here for this one. 2x plus 1 over 2 minus 1. So this is what we have here. And then 2 times x plus 1 over 2, then there will be the simplification here. We have x plus 1 minus 1, so it's x. So as you see, both, they give x, they are their inverses of each other. So when showing a function is the inverse of the other one, or the functions are inverses of each other, then we have to show these two conditions. Now, if exists, so it means it might not exist. Like, you know, if it is not one-to-one function, it doesn't exist. But if it exists, if function is one-to-one, then the inverse of a function f is denoted by f minus 1 here. F superscript minus 1. And this doesn't mean the power. Okay, don't confuse this one with the power here. This one denotes, in the literature, in the books, this one always shows the inverse function. It's not 1 over f of x. It's, you know, this notation and this notation, they don't mean the same thing. Okay, so this is one important thing to note. Now, some remarks on f inverse, the inverse of f. So it is obvious that if f of a is b, and then the inverse of b is equal to a, so what we know is, okay, now you will see it now. It's a, f takes a to b, and now f inverse takes b back to a. This is what happens here. And then the domain of f is the set of inputs here, and this is the range of f, the outputs for f. But if you think of the f inverse here, so the range of f becomes the inputs of f inverse, so it becomes the domain for f inverse, and this part, I mean, this set becomes the range of f inverse. So these are the two other things to know. Okay, let's look at this example. In Okay, by using this diagram, I mean the function, the rule, and the rule of the function is given by this diagram here, and it says find f inverse of 5, f inverse of 6, and f inverse of 7, and determine the domain and range of f inverse. So f is going this way, so f inverse should go the other way, backwards. So then you can say what is the f inverse of 5? So it will go back to 1, and 6 will go back to 2, and 7 will go back to 3. And what about the domain? Domain of f inverse is the range of f, so these are the inputs, so this will be the domain, and this will be the range of f inverse. So here is the sets here, set in list notation, set notation. Now, finding the inverse of a one-to-one function. So how can you find the inverse of a function? So we will follow two steps. There are several methods for this, and in the other books, there are lots of methods. I mean, especially one or two methods are the very common ones. We will show you this one here. Solve y equal to f of x for x. So it means find x in terms of y. Then replace y with x and x with f inverse of x. So another method here is, in some books you can see they say replace x and y first, then solve for y, and change y to f inverse. This is another method. You can use also this one. I mean, whatever you want. You can use both methods, but here in this slide we will show you this one. If you learn it in high school and if you do it this way, it's okay. But since in our slide it's given this way, so I will give it this way. Like the solutions of the examples will be this way. Now let's look at this example. So find the inverse of the following functions. Let's go step by step. First solve y equal to f of x for x. So it means, so you write y equal to 5x minus 2. And then solve for x means isolate x. So you get 5x and divide by 5. So we got x equal to y plus 2 over 5. And then replace y with x. So you will have this one. And x with f inverse of x. So get the inverse of f as x plus 2 over 5. And we can do the other one the same way. Now let's look at this one, y equal to 1 over x minus 1. Now we want to get this x equal to what? So we will try to, okay, how can we get rid of the denominator here? So we don't want this here, Makam. So you multiply both sides with x minus 1. So we will get x minus 1 times 1 over x minus 1. This becomes, 1. And we will try to get x isolated. So you can multiply these. I mean, you can distribute y to xy minus y equal to 1. And this gives you xy equal to 1 plus y. And okay, we have x here, and I want to isolate x. So I divide both sides with y. So here we get this one now, x equal to 1 plus y over y. And I use the second step here, y, replace y with x, so make this one x, and then x, replace x with f inverse of x. So then f inverse will be x plus 1 plus x over x. Now I want to show the solutions here in the slide. So it's basically writing, okay, it's doing the same thing as I did. Now let's look at this try and check example exercise. Please stop the video and try to do it by yourself. Then you can compare your solution with mine. Find the inverse function of each of the following functions. The first one is f of x equal to x plus 5 cubed minus 1. Now, first you write this one as y equal to x plus 5 cubed minus 1. And then you will do the step 1 here. Step 1 is solve for x. It means isolate x. Isolate x means make it alone. So y equal to x plus 5 cubed minus 1. So send 1 to the other side. You have y plus 1 equal to x plus 5 cubed. And now we want to get rid of this cube here. What we can do here is the cube root, taking the cube root of both sides. And since we have cube root here and this is odd, we can directly say this is equal to x plus 5. And if it is x plus 5, we can change, we can send this to the other side. It will go to the other side and it will give us this result. And after doing this, we got x. So step 2 is this one now. Change change y to x and x to f inverse of x. So do them simultaneously. So it means f inverse of x should be equal to change x with f inverse and y with x. So it will be cube root of x plus 1 minus 5. Okay, for the yes, so we got the inverse function. Now we can do the same thing for the second one. One problem here might be solving the equation. So this is important here. You have to solve this equation in terms of x, and you see there's also y in it. So it's a literal equation. So you're trying to solve a literal equation. So you have to be careful here. So for this one, you first write it as y equal to x over x minus 1, and then isolate x. So it means solve for x. So how can you do that? We have to get rid of the denominator first. So how can you get rid of the denominator? You multiply both sides with x minus 1, and then you will end up with x minus 1 times y equal to x. And then we have to collect, you have to collect all x's one side. So here we expand it again. We have this one, and x is here and x is here, but I want them in one on one side. So in this case, I would do, okay, I can do this one. Send this one to the other side, and you will end up with x minus xy. And as you see here, we have minus y equal to x times 1 minus y. And then I want to isolate this one. I want to have x alone. So for this reason, I would divide both sides with 1 minus y. So here, I got this one now. X equal to minus y over 1 minus y equal to x. Then the step 2 is step 2. X should be replaced with f inverse of x, no, g inverse of x here, because it was g here. And then y should be replaced by x, so g of inverse of x, g inverse x will be equal to minus x over 1 minus x. If you do the minus issue here, like you can take it to here and multiply with it, so you can end up with x minus 1. So check this one, please, because if you say something like this, then you can write it as like 1 over 1. I mean minus 1 minus x. You can take this to the denominator, and then you can multiply, and you will end up with 1 minus 1 plus x. You can write it this way. Graphing the inverse functions. Okay, the idea is this. Like this picture is enough to see what's the relation between the graph of the function and its inverse. Now, assume this is the graph, your function's graph, f of x, y equal to f of x graph. And here is the important thing. The graph of y equal to f inverse of x is symmetric with respect to, the graphs of f inverse and f, they are symmetric with respect to y equal to x line. So y equal to x line is this, y equal to x line is this. You have to draw this one, and then take each point and look at its symmetric, its reflection through the y equal to x line. So take these points and look at their reflections, and then this points here will give you graph of y inverse of f inverse of x, the graph of f inverse. So basically, to get the inverse of a function, the graph of the inverse of the function, you take the reflection of the function with respect to y equal to x line. So this is a Neve type reflection, because we have seen the reflection for the x-axis, for the y-axis, for the origin, but this time it's with respect to a line, y equal to x line. Okay, so let's solve this problem here. So it says, sketch the graph of y equal to f inverse of x if the graph of y equal to f of x is the following. So we want to get the graph of the inverse of f, and the graph of f is given here. So, okay, the idea is to check the reflection through y equal to x line. So what is y equal to x line first? So where is it? Y equal to x line. So if you don't know it, like the easiest method is 0, 0, 1, 1, put these values here. So then you get these points, these points, and you will get this one. And then it will give us, okay, we take the reflection of this. It will be this one, and now you take this point and look at its reflection through that point, through this line. It will be like that. So you will end up with this. Okay, look at here. So here is what we told you. Y is equal to x. This is f of x. So you take a point, you'll look at its reflection through the y-axis. So it has to be 90 degrees here, and they're the same distance. Now let's do this try and check exercise. Sketch the graph of f of y equal to f inverse of x if inverse of f if the graph of y equal to f of x is the following. So the y is equal to f of x graph is given to us. Now we want to find the inverse function graph. So the first thing you have to do is, y equal to x line. So draw step one, let's say step one, draw y equal to x line. So to get this line, you can use the table here. So if you take -1, y will be same as y. So 0, 0, 1, 1, 2, 2. You will put them in here on the graph, then on the Cartesian coordinate system, and you will get these points like 1, 1 is here, 0 is here, and -1, -1 is somewhere here maybe. We have the other points, but this 2 point is enough for us. So this makes the y equal to x line. Okay, here I did a thick line, so I will make it a little thin. Zero, 0, 1, 1. Okay, this makes y equal to x line. Now, step 2, reflect the graph of y equal to f of x across the y equal to x line. So y equal to x line is this. So how do you reflect? You reflect the points. It's better you do point by point. So take a point and go to the other side with 90 degrees and the same distance. Stop here, and you take this one. You stop somewhere here. It's all 90 degrees. So we have this one. And if you do the same thing for the other points, you have this one. So you connect all the points here. And you can take also some points here like that. So this point will come to here. So this is the graph of y equal to f inverse of x. So then this is the graph of y equal to f inverse of x. So now, to this, we can erase this one. In any case, it's better you leave it there. If you're asked to do it, it's better you show y equal to x line. You don't need to erase it. So to make the function clear, I'm erasing it, but you don't have to do it. It's better you keep it there. So you can make it like this. This is y equal to x line. Now, finding the inverse of a function on a restricted domain. Now, one thing about the inverse functions, we said the function might not be one-to-one. So, for example, this function is not one-to-one. Not one-to-one. But if you take only this part, it's one-to-one here only, here. If it's only one-to-one here, okay? But if you think all, no, it's not one-to-one. So you can check the, online horizontal line test. So it says exactly this one here. It states this one. If a function is one-to-one on a restricted domain, so it means on some part of its original domain, then it has an inverse on this restricted domain. For example, look at this, the absolute value function. This is not one-to-one clearly because the horizontal line here, we draw a horizontal line and we see 2 points intersecting with the graph. So it says it's not one-to-one, not one-to-one, right? But so this is not one-to-one on this interval here, right? But if you restrict it into the only positive part, it's only for x bigger than 0. So then you don't take this part, you just look at this part. So for this part, for each horizontal line is passing through only one point on the graph. So in this case, it's 1 to 1. So it's 1 to 1 on the positive side, positive x-axis. So you can say y equal to the absolute value of x is 1 to 1 on this part only, not the other part. So in this case, we can find the inverse of this function only on this part. So when finding the inverse on a restricted domain, we apply the usual procedure. We need to make sure that the range of the inverse function is on the restricted domain. So if you want to, if you want to go back from 1 to the y value to the x value, you have to. So the idea is this: 1 can go to 1 and minus 1, right? When going back, it can go to minus 1 and 1. So this makes the problem. But if you restrict your domain, so if you don't take this part, so if you restrict your domain to here only, then the inverse of the absolute value, the inverse of this 1 will be 1. So this is what this sentence is telling us. So we have to make sure that when we go back to this x has to be on this part, not the other part. So let's see it in one example here. Look at here. So it says find the inverse of this function, and this function is given on the negative side. So here this is x squared function. It's not 1 to 1, but it says take this part only. Take this part only, because which part is it? This x is less than or equal to 0 part is this part here. I mean, we are taking the picture of this part, so it means we are taking the picture only this part here. So we are not interested on this part. So it says find the inverse of function here. Okay, we will not do anything with the graph. So you can do also with the graph. I mean, y equal to x is this, and you can take this one here. But anyways, we are interested in finding the formula for f inverse of x. So the procedure is normal. The usual procedure is what, like, you have to write y equal to x squared, then solve it for x. So when you solve it for x, like when you do this one, you will end up with this. When you solve it for x, you will get this plus minus square root y, right? So we have two x values. But what does it say? It says x is less than or equal to 0. What does this mean? X cannot be positive square root y. Okay, it says x should be minus square root y. And you will take this one and do the next thing, which is f inverse of x is equal to minus square root of x. So because y changes to x and x changes to f inverse of x. So here, this is very important here, because when you solve for x, you will get two values and you will decide which one. Then after you find the correct one, you will go to this to this procedure. I mean, this changing x to f inverse of x and changing y to x. Okay, here is what we have. You solve it for x, you isolate x, you get two values, and now you pay attention to what is x here. X is less than or equal to 0. It means x should be the negative one. And then you replace x with f inverse and y with x. Okay, let's look at this try and check exercise. Show that f of x equal to x minus 2 squared plus 1 for x bigger than 2 is 1 to 1, and find f inverse of x. So how can you show it's 1 to 1 on this side? So to show it's 1-to-1, it's better the only method we have seen so far is to make the graph of it. Okay, let's do the graph of this. This is, okay, I will use some previous knowledge. X squared goes to x minus 2 squared, and then it goes to x minus 2 squared plus 1. I think if you remember the transformations, the vertical shift, horizontal shift issue, you will see this is like 2 units, right? We are shifting this x squared, the graph of x squared, 2 units right, and then 1 unit up. Then we do this in this procedure. We use 1 unit right, 1 unit up. So then this x squared becomes 2 unit right and 1 unit up. So it means here. So let's make the graph, and here this is the graph of this function here. Okay, this method here, we learned this shiftings and the other things for this reason. This is easy shortcut. This is the shortcut of short way of making the graph of this function from x squared. And now we have this point here, 2, 1. And it says for x bigger than 2, it's 1-to-1. So we take, so x bigger than 2 is this part here, right? So we take this part. Now we erase this part. I mean, we are not interested. Okay, you don't have to erase, but we are not interested in this part. So for this part, so you see these, the horizontal line test succeeds. You know, it's successful. So this function here, it is 1-to-1 on x bigger than 2 part. Okay. Now we know it's 1-to-1. Now we have to find the inverse. So the procedure for the inverse is, again, it's same as before. So we write y equal to x minus 2 squared, y equal to x minus 2 squared plus 1, and then solve for x. So how can you do it? So by the way, you can send minus 1, send this one to the other side. You have y minus 1 equal to x minus 2 squared, and then take the square root here. From the square root, you got 2 roots here, like, right? So we have, okay, I want to show you the thing here. Take the square root, you have absolute value of x minus 2. This is the proper way of doing this. I don't want to say it's just like plus minus, but this plus minus issue comes from the absolute value. Okay, I mean, you can skip this step, but what I don't like is some of the students always say like square root 9 is equal to plus minus 3. No, this is not true. This is not true. When solving it, you know, when solving it, we say x is equal to plus minus 3. Okay, we never say square root 9 is equal to this. No, this is never true. Okay, now we have 2 things here, like 2 plus minus square root y minus 1. So which one we should take? We should take which one? This is the important question here. And we look at the condition on x. X is bigger than 2. And which one is bigger than 2? So of course, we have to take with the positive one in order to get bigger than 2. So we take, so I say, okay, I take this one because x bigger than 2, I take x equal to 2 plus square root 1 y minus 2, because it's more than 2. You see, it's plus, it's always positive, so it will be bigger than 2. And then the next thing is we will replace x with f inverse of x. So step 2 is, now we solve it, and now change x with f inverse of x, then y with x. At the same time, you're doing it simultaneously. And we have this one, then f inverse is equal to 2 plus square root x minus 1. Finding the inverse on a restricted domain is important in some cases, especially when defining the inverse of trigonometric functions. We will use it in the second semester. Anyway, that's the end of the sections and the chapters. Thanks for watching. Hope to see you, inshallah, next semester.